Okay, so let's start where we left off. I think this is the one. No, where is home page? Let me open Cbon. What happened? Oh, let me again restart it. Wait, come on. Done. Let me open. Come on, come on, come on, come on. Yeah. Okay, so let's move ahead and let me just re-import everything again like this and Cbon, this one. Okay, now see everything. So basic analysis of every visual, why it is required, your univariate analysis, your bivariate analysis, right? And even your in bivariate, continuous versus categorical, and those graph, right? We have seen how to find out the outliers, how can we remove those outliers that we have seen, right? And we have also seen the bar plot and everything, count plot, bar plot, different plots we saw, okay? We also saw a very important plot known as box plot that we discussed, okay? Then we discussed how to remove the outliers, what is the rule for the same, and further we categorize everything. We saw violent plot, which is very much similar to your box combination of box plot and KDE plot, okay? And one thing that was important actually that I want to tell you now, because it's time to come to tell that, one example, we was plotting a bar plot, right? Between a time and the tip example. Between time and the tip, we were using this bar plot. So let me copy the same structure again. Okay, come on. Yeah, come here. So same, I'm doing that. If I go inside, by default, what it will do, it will take on the x-axis your time, and on y-axis, okay, it will give me the result. But remember, whatever result you will be seeing, that will be the mean tip. That will be the mean tip or the average tip that we saw yesterday, right? So whatever you're seeing, lunch and dinner, this is the mean tip paid at the lunch time. This is the one, 2.78 something, okay? This is also the mean tip paid during the dinner time, what you are witnessing right now, okay? But suppose you want to change it. No, I don't want to see the average. I want to see min, or I want to see max, or I want to see sum. Yes, we can see that. But by default, the estimator that is available here is mean. If I go inside and shift and tap together and see here, there is an argument known as estimator. Okay, it's mentioned function mean. If there is a function which calculate means, the function name is mean, and which is stored at this particular memory location. That's what it is using, but you can change it. Okay, right now what you are witnessing the mean value. Okay, but I want to change it. Then I can use the parameter estimator. Again, same thing that was mentioned there, estimator. We press tab, automatically complete. Now, what I need to mention here, understand the function that you want to use. Okay, instead of mean, you want something else. So you have to tell that estimator what is that estimator, right? So we have different estimators. Suppose I want to see minimum value. Instead of this mean value, I want to see minimum value. So I can mention numpy dot mean method. Sorry, not mean method, min method. np dot min method. But for the same purpose, if I execute, I will get an error. Let me execute this. See, it is saying name np is not defined because I've not imported numpy yet. So let me import that. Import numpy as np. And after that, if I execute, I will see minimum value, okay, in that tip for lunch and dinner instead of mean value. Can you see everyone? Now the result changed. See, let me make it mean again, back mean. See, this is the mean value. What we are witnessing right now, mean value at the lunch time, mean value at the dinner time. But I want minimum value at the lunch and dinner time, so I can make it min, np dot min method. So I'm getting this min. At lunchtime, minimum paid tip is this. Dinner time, minimum paid tip is this. I want to see maximum, so just change it to max. So this is the maximum. Maximum during the dinner time is around 10 rupees. Maximum during the lunch time is around 7 rupees. You want to calculate total sum of the tip paid during lunchtime, sum of the tip paid during the dinner time. So instead of max, you can make it what? Sum. Like this. Done. This is, sorry, test one. This is the sum that has been paid total during lunchtime or the dinner time. I hope you got an idea, everyone. How can we change this estimator according to our requirement?
Yes, sir, we got the idea.
Okay, remember, so as per your requirement, by default will show you mean only, right? But sometime, normally we compare with the help of mean only, but if sometime you want to compare with the help of maximum value or minimum value or mean value or standard deviation, even you want to change, you can do that. Example, instead of sum, I can mention standard deviation like STD. See, so this is showing me standard deviation. So whatever you want to change is your choice. As per your requirement, you can mention anything. Suppose I mention here sum. Done. Right now, I hope everyone, if I give you a data set, from that data set you can do complete univariate analysis and complete bivariate analysis. Okay, you should be capable of doing, because now you know pandas very well, you know group by method, you know everything, right? Pandas very well, you know matplotlib very well, you know seaborn very well. If I give you a data set this time, okay, you should be able tell me complete univariate analysis and complete bivariate analysis along with the finding, what this graph is saying, what this graph is saying. You should give me, tell me that. That is your EDA part. That you should do exploratory data analysis. Now you should be comfortable in doing that. We will spend at least 7 to 8 hours, more than 7 to 8 hours, only on EDA, starting from the pandas only. At least 8 hours on EDA, complete EDA. Okay, so you should know how to analyze the data properly, how to read the data first of all, how to check the missing values and everything, how to check for the outliers, what is the relationship, correlation, okay, what is the max value, minimum value, the comparison between the different visuals. Yes, you should be able to do that. Okay, now we are in situation to start our machine learning. For next 7 to 8 sessions, we'll be dealing with machine learning algorithms only. Okay, because basic foundation and be strong. Making machine learning model barely a task of 5 minutes, not more than that, but understanding them, it is a crucial thing. Okay, so let me come to that. Okay, so hopefully today itself I'll give you a task. Understand that task will be a data set. You have to analyze that complete data set, because what will happen, understand, when now at least in 7 days, understand, in 7 days we will be 7 to 8 sessions more, we will be completing everything. But by that time, understand everyone, I will give you 4 to 5 data sets. At least take 3 data sets. Okay, and do complete EDA of those. Complete EDA from beginning till end. Complete EDA. What is the finding? What is the finding? What is the finding? What is the finding? Everything noted that. Okay. Once you are ready within 2 3 days with all your 3 to 4, once you understand how the machine learning algorithm is implemented, trust me, this is a matter of 2 minutes to build a machine learning model. If you, because maximum time is saved, is devoted in the EDA. Maximum time. We have been doing that 8 hours, right? For 8 to 9 hours, we have been doing the same thing. So maximum time that takes is in the EDA part only. So if you can devote 5 hours, 6 hours for one data set, devote it, experiment it, what is your finding? Create that. At the later stage, only leave yourself for what? Building your machine learning model. Only one, I will just import the library and it will be done within few seconds. You don't have to worry about building a machine learning model. The main part is the EDA part. That's why data analysts are highly paid. If you can analyze the data very well, most of your problems will be solved. Right? Now move ahead, everyone. So we understand the EDA, right? After the EDA, what we will do? We will do data pre-processing. Means if a machine learning model is given to you, design is asked from you to design. So you understand your data, you do all exploratory data analysis. Then what you will do? You will do your data pre-processing. What do you mean by data pre-processing? Understand everyone. What do you mean by data pre-processing? Nothing but it is a process of making your data, making your data suitable for machine learning. Okay, it is nothing but a process of making your data suitable for training your machine learning model. Okay, suitable for training your machine learning model. Directly, we don't use the raw data. We have to do some pre-processing. What pre-processing we may require? Understand? Okay, first pre-processing that you may require, understand everyone, will be to deal with missing values. To deal with missing values. It is primary thing. If you want to build a machine learning model, you should not have any missing values. You should not have any missing values whatsoever. If there are the missing values, there is a trouble for you. Okay, there should not be any missing values. First thing that you will deal with that. Either remove those missing values, means remove those rows which are having missing values, or impute there. Impute means substitute something by the something. I'll tell you an example, don't worry. Okay, so first thing that you will be required to deal with the missing values. Next thing that you will require, very, very important again, convert text data into numeric data. Because your machine learning algorithm understand only numbers. They don't understand any kind of text. Okay, so you have to convert your text data into numeric data. Very, 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 very important thing that you want to do. At most important. So two are the primary things that you have to do at any cost. Deal with the missing values and convert text data into numeric data. When you are training your machine learning model, at that time, you should not have missing values in your data set. If they are there, please deal with that. Either remove those rows which are having missing values or impute something. Impute means substitute something where the missing values are. Okay, two primary things. These things though you have to do at any cost. Okay, these two things though you have to do. This is mandatory. Third thing what you can do, okay, is to deal with outliers. Okay, to deal with the outliers, because outliers may strongly impact your machine learning model. But please don't directly go and remove the outliers. Sometimes it may be possible your outliers are important for you. Okay, your outliers may be important for you. They are giving you strong information. So always understand what is the requirement accordingly. Deal with the outliers. So to deal with the outliers, mostly we will remove them, but in certain cases, it is important that you keep the outliers. But most of the times we remove the outliers. Most of the time, that is the most commonly preferred scenario. Because suppose I want to calculate average salary, then makes no point in calculating average salary with the person which is having outlier, nor different from that trend. Okay, but sometimes even outliers are important. So deal with the outliers. Fourth one, again, very, very important. Okay, see, scale or data. Scale your data. What do you mean by scale your data? Understand. Suppose I have few parameters like salary, okay, age, height, okay, weight, something like that. Okay, and accordingly, let me mention in another page that is better because we have a very less space here. Let me come here. I'll come back to this again. Yeah, come here, right? On this, see, what happened? You for a company you want to design a prediction model. What is a prediction model? Whether the person will buy a car or not. Person will buy a car or not. Okay, so somebody buy a car or not. So somebody came for the showroom and you entered his information. What you answered, asked him his name. What is your name? Right. After the name, you ask his age. Okay. After that, you ask his gender example. After that, you ask, sir, what is your salary? After that, suppose you ask, sir, what is your weight? After that, you ask, suppose, what is your height? Something like that. Okay. And finally, your result output, whether the person will purchase car or not. Purchase or not. Yes or no. Okay. So somebody's name is entered, suppose A, age is 23, gender is suppose male, salary is suppose 5,000. Okay. Weight is suppose 50 kg. Height is suppose 170 centimeters. And suppose the same kind of data, somebody purchased the car, yes. Again, somebody else came, age was 25. Gender is again M. Salary is suppose 50,000. Okay. Weight is suppose 60 kg. Height is suppose 180 centimeter. And he doesn't purchase the car. Suppose no. Something like this. Okay. So in machine learning model, what we actually try to do, what is our objective? We try to find out a relationship between my output variable, means what is the output variable this time? Whether the person will purchase a car or not. Whether the person will purchase a car or not. So we try to find out the relationship between my output variable and these input variables, some sort of relationship. Okay, some sort of relationship. Relationship can be anything. Like example, I used a coefficient W1 into name plus W2 into age. I'm just giving an example. Plus W3, these are weights or coefficients, right? Means how much weightage this particular variable is having. How much weightage this particular age will have. So we use some coefficients, example, W3 into gender. Okay, something like that. Plus W4 into salary. Okay, of course, don't worry about these name because these are right now text columns. So don't bother about this. Consider on this age, salary, weight, and height. W6 into height, example. Right, this is my output equation that I try to find out. Okay, so we come across there will be some weightage. Okay, what is the coefficient of the name? Means if it has a lesser weight, means it has a smaller contribution. If something has a larger weight, means it has a stronger computation. Okay, or we can say this way, whatever is giving me larger value, of course in output that will have a more weightage. But let's see what happened in this case. We have a different scale of data. This age is coming between 23 and 25. Okay, salary will have 5,000 and 5 means it is in thousands, right? It is in under 100. It's in decimals. Sorry, not in decimal, it is in tens. Sorry, it is in tens, 23, 25, something. Okay, even this is in tens. Suppose it is in hundreds. Fine. So what happened, remember, the larger the quantity will become, the more its weightage will become automatically. Of course, when I'm writing an equation, when this is 5,000, of course, we're deciding everything. Everything is decided by salary. Rest of the quantities are very small, 25, right? Even 50 kg, 60 kg. This is 170, 180. But suppose 5,000 is there, 10,000 is there, 50,000 is there. So which is the major contributor in overall equation? Of course, salary, right? So this will impact more in my machine learning model, right? Because its number is high, it's large in number. So to get your proper machine learning model, remember every numeric data, okay, means your numeric data should be properly scaled, especially in those scenarios which are distance based algorithms where some distance matters. Okay, where distance matters between the, we'll see what is the distance based algorithm, don't worry about that. Means especially where distance is important in those algorithms which is probability based, in those scenarios this doesn't matter. What is this, where different machine learning algorithm which are probability based. Okay, in those scenarios what doesn't matter what it is having, doesn't matter what it is having, doesn't matter what it is having, the scale can be different. But some algorithm which are distance based algorithm, in such scenario, what is ideal condition? They should have the same scale. They should have the same scale, means everything. Normally what we do, we put everything normally. They should be in the same range. So suppose what we do, understand, example, I'm just giving an example. We divide everything of every column, whatever column is. I'm just giving one example, not exactly, I'm just telling you how scaling you can do. Do one thing, take every column and divide it by its maximum value. Take every column and divide it by its maximum value, whatever maximum value in this. Similarly, whatever maximum value in this, whatever maximum value in this, means divide every value by the maximum value in that particular column. So one thing is guaranteed, in every column, the values that we'll be having will be always between 0 and 1. Tell me everyone, right or wrong? Tell me.
Right, sir.
Right? Everything will be between 0 and 1. That means everything will be in one scale. Okay. So effect of this will not dominate anymore. Right? Yes, Varun. Right? So now effect of this will not dominate anymore. This is what I mentioned in this slide. Okay, scale your data. This thing we may need to do. Right? Next thing, what we may need to do. Come on here. Fifth one point. We may need to deal with the skewness of the data. Skewness of the data. Right? Your ideal distribution should be like a normal distribution, very much like this. Right? But if you are getting this kind of data, this is your right skewed data. Okay, if I am getting this kind of data, this is your left skewed data. right? So we will try to convert this kind of graph into this kind of graphs to deal with the skewness. This is nothing but dealing with the skewness. But remember, these things what I mentioned, deal with the outliers, scale your data, deal with the skewness is not mandatory. Depends on your requirement. The better work you do, of course, your model will be better. Same machine learning model, I am working, I may achieve 60% accuracy, and you are working, you may achieve 99% accuracy. With the same data, everything same, depending on how much time you have devoted in analyzing your data. That's why it is what data scientists, they're analyzing the data. Means scientists, they are of the data. Do research on the data. That's what the data scientist means. The more research you do in your data, trust me, you better your machine learning model will become. More time you will spend. Right? So this pre-processing we may need to do, deal with the missing values, convert text data into numeric data, deal with the outliers, scale your data, okay, and deal skewness of the data. Everything of this we will see when we will write coding of our machine learning model. Every of these steps we will see. Dealing with the missing values, converting text data into numeric data, dealing with the outliers. Although dealing with the outliers, we have already seen how to deal with that yesterday. Remember, we saw what is the rule. Remember?
Yes, sir.
What is the limit? Q3
We
plus
find
1.5 times IQR,
yeah,
right? And Q1 minus
1.5
1.5
times
times of
IQR.
IQR, right? So we can filter our data frame as per our requirement. It will be done. Okay, but we will see scale your data. I give you a hint. How can we do that? Not mandatory that you always use the rules which have somebody has defined. You may create your own rule, how you want to scale. It's your choice. Different scaling methods are there. Min-max scaling is there, standard scaling is there, different scalings are there. So you can use that way. Okay, for dealing with the skewness, different methods are there. Not mandatory you become, okay, this has been written this, I will do this. No, it may be possible you may your device a particular method which is doing better than what has been written, mentioned in the books. Quite possible. You are also exploring the data. Now you are a data scientist, so you may give a method which is better than any given by anybody else. That's the bet. And here comes very important thing known as domain knowledge. Right? So if you are working in any particular domain, you of course you will have very decent knowledge about your domain. Somebody is working in the automobile, okay, and it has been given the machine learning task to do. So of course he knows very much about the automobile. But suppose same machine learning algorithm is given to me, which is having automobile data set. Of course, trust me, I will not do that well that the person will do which is working in the automobile industry, because he has the domain knowledge of his industry. What is happening there? Right? This is how the domain knowledge comes into the picture. Very important. Even if you apply for the data scientist role, they mention that experience in this particular field is required. Experience in this particular field is required because experience has no comparison. And this is what machine learning is, right? It learns from the experience only. It learns from the experience only. So now move ahead. Okay, I'm moving ahead. Yeah. Come this. Okay. So basically, there are three kinds of machine learning algorithms. Understand? If we talk about machine learning algorithms, there are three kinds. One known as supervised machine learning algorithms. Right? Second one known as unsupervised. Okay, and there is a combination of both of these known as semi-supervised. And third one algorithm on the people are doing a lot of research. Still it is going on. Still it is going on. Okay, that is your reinforcement learning. Okay, it's still a huge research is going on. We are not yet successful. You must have heard about a self-driven car. Everyone
Yes,
heard
sir.
about, right? So
Yes, sir.
it is being designed on reinforcement learning only, but unfortunately it is not yet successful 100%. So people are doing lots and lots of research. So you will find few applications of the reinforcement learning as well, but it is a hot topic. The research is going on. I'm still learning it. I cannot say even I know 50% of the reinforcement learning, okay, because I'm still in the learning phase of this. But yes, we can easily deploy our supervised and supervised machine learning model very easy without any problem, because it's still research is going on. I read something, let's just see, okay, this research is, no, this is not good, do this thing. So I still the research is going on. People are doing that research, and huge amount of research is going on, right? So let's come to what is supervised and what is unsupervised and what is reinforcement learning. Okay. So what is supervised? See, in supervised learning, we will have our input variables, okay, as well as our output variable. Both the things will be given to you. Input variables as well as output variables. Both the things will be given to you. Input and output. Example, it may be something like that. Somebody's height is given. Okay. Somebody's weight is given. Okay. Somebody's complexion is given. Okay. Example. And from that, you have to guess whether the person will be male or female gender. From height, weight, and suppose age is also there. Age is there, height is there, weight is there, and complexion is there. Something like this. Example, complexion doesn't suits here. Let me take age, height, and weight. And suppose I miss ethnicity. Okay, which country they belongs to, Asian or African or European or American, something like that. Ethnicity is given you. Okay. So what is given? Age. Suppose somebody's age is 23, height is 170 centimeter, weight is 70 kg. Ethnicity is suppose Asian, and he's a male, right? Somebody's age is 23, height is 150 centimeter, weight is suppose 50 kg, and she's also Asian. Suppose she is female, right? Similarly, somebody's age is given 32, height is 160, weight is suppose 55 kg. She is belongs to Europe, and she's female, right? Again, something suppose 40, somebody's age is given 40, height is 190 centimeter, weight is 90 kg, and he belongs to America, and he's a male, something like that. So 6 kind of data set is given. This is historical data which is given to you. Okay, so these are your input parameters: age, height, weight, and ethnicity. So actually what I have to do, from these parameters, I have to predict whether the person will be male or not. Means person is male or a female. I have to predict his gender. Okay, so what is my output variable? My output variable is what I want to predict. That is my output variable. This one, output variable, or sometime this is also known as output variable, or label, or target. All are synonyms. Some people call it as a target variable. Some people call it as a label. Some people call it as an output variable. Right? So in supervised learning, you will be given your input variables or attributes. Okay, input variables will be given to you. These are input variables: age, height, weight, and ethnicity. And at the same time, what will be given to you? Your output variable will also be given to you. It will be given to you. Means always how what we do in machine learning algorithm, we learn from the historical data. So some historical data is given to you. According to we are classifying supervised or unsupervised. In this historical data, what is available to you? You have available of input variables as well as some output variable. Based on the basis of this, what we try to find out the relationship between my gender, which is my output variable, and my input variables like this: age, height, weight, and ethnicity. Right? So my output variable is a function of age, height, weight, and ethnicity. So when data will be given to you, in that data, if you have an output column available with you in a training data, okay, if you know training data or in your machine historical data that is given to you for training your machine learning model, okay, they will be giving you some historical data. This is the historical data. From that only you will learn the model. No? How will you learn the machine learning model? Of course not. Okay, example, give me an example. Suppose I'm writing something here, x and y. I'm mentioning here 2. Okay, I'm getting here 4. I'm mentioning here 3. I'm getting here 9. I'm mentioning here 4. I'm getting here 16. I'm mentioning here 5. I'm getting here 25. Can you get what is the relationship between x and y? Everyone, suppose this is my input parameter and this is my output.
So x is
Y
square
equal
root
to
of
x.
y.
X is square root of y. But this is my output parameter. Yes, you are 100% right. Absolutely right. Or we can say it is nothing but y is equal to x square, right? And how you came to across this information, everyone? By looking at the story, the data that I wrote here, right or wrong? By looking at the data, only you are able to predict this relationship. Clear, everyone? By looking at the data, you look at the data, right? Suppose I just mentioned this x sorry, X and Y, and I give just one parameter, 2 and 4. Can you tell me what is the relationship between them with 100% confidence?
No.
No. It can be 2 into 2, right? It can be 2 square as well, right or wrong, everyone?
Can be 2 plus 2.
Yeah, it can be 2 plus 2 as well. Absolutely. Right? But when I give you more historical data, right? I mentioned this 2 is 4, 3 is 9, 4 is 16, 5 is 25. Then means when you have a more historical data, you can strongly say, this is my relationship. What? Y is equal to X square with the confidence. But how you are doing that? Same thing. You understand this right now. And by looking at the eyes, you understand, okay, what is the relationship between Y and X? You said Y is equal to X square is the relationship. Right? You are doing, but not we have to do. We have to do, give this this task to someone. What? That is your machine learning algorithm. Machines, you learn what is the relationship between X and Y. Okay, so how you learn? The same way, I give you some historical data. From that historical data, you analyze and you say, okay, this is the relationship between Y and X. Now, suppose I give you this data. After giving this data, I tell you, please tell me if I pass 6 here, what I will get. Can you tell me the answer?
36.
Very good, right? Means your machine learning model is already trained, right? And what is your model? Model is this simple. This is your X, and model is nothing but X square. That's it. That's it. But how it guessed? Before doing anything, you predicted X. What I did, I passed both X and Y to my machine learning algorithm. I trained this. Okay. It learned by looking at X and Y and said, okay, the relationship between Y and X is what? X square. Y is nothing but X square. When it has been done, my machine learning model is trained. Awesome. Now I can give new data, example 6, and I can tell my answer will be 36. Right? This is what I did. I give you input and output together. Input is available, output is available. I give you some historical data. From that historical data, looking at the result, you include that this is the relationship between Y and X. Okay. And you find out this relationship. Now you tell me, machine learning model is trained because your equation is found out. Once the equation is found out, I can give new value of Y, so new value of X, and you can predict Y. This is what machine learning model does. Instead of manually looking at, we will pass these parameters, age, height, weight, ethnicity, and gender. Okay, this complete historical data, which is available here, to my machine learning model. And my machine learning model will try to find out the relationship between my output variable and my input variable. What is the relationship between them? Once it is done, you will say my machine learning model is trained. Now you can use it. Okay, so in supervised learning algorithm, what will be given to you? You will be given input variables, and what will be given as well, everyone?
Output variable.
Output variable. And why this output variable is actually supervising you? What is the what should be the equation? What should be the equation? This is what it is supervising. How you come to the conclusion? By looking at the Y. Okay, 2 it is 4, 3 it is 9, Y is so it is helping you out, na? Right? This is helping you out. So in your supervised learning algorithm, remember your we call that, we will get labeled data. That is a better word. We said we get labeled data. Labeled data means what is a label? Remember your output variable. So in your data, you will have input variables as well as output variable. Clear, everyone? What is supervised learning? Please tell me. What kind of data will be given to you? Labeled data means you will have input variables as well as output variable. You will find out relationship between output and input variables in supervised learning by using your historical data. Clear? Please tell me.
Yes, sir.
Okay, this is just supervised. Now come to unsupervised. What is unsupervised? Now you will get unlabeled data. Unsupervised. You will get unlabeled. Means what will be missing, everyone?
Output variable.
Yes, output variable will not be given to you this time. Okay, so what happened in supervised learning algorithm? Suppose x1 is one input, x2 is one input, okay, and y is your output. So in your supervised, x1 will be given to you, or x2 will be given to you, y will be given to you as well. Example 1, 2, 1, 2, 3, 4, 4, 5, 6. From this, looking at this, you will try to find out relationship between y and x1 and x2. This is your supervised, but in unsupervised, this will not be given to you. No, you will have only and only input variables. You will have only and only input variables in unsupervised. So there is no one to supervise you to find out, okay, this should be the correct relationship. Nobody is there to guide you. So what we do here in this unsupervised learning algorithm, when we have unlabeled data, we try to find out patterns among the data. We try to find out patterns among the data. This is what our requirement is. We try to find out patterns among the data. How? Understand? Suppose I have two variables, input variables, x1 and x2. Okay. And an x1 and x2 are giving something like this. Suppose 0, 1, 2, 3, 4. Okay. Again, 0, 1, 2, 3, and 4. And both are input. Remember, this is input, this input. But output is something like that. Mention something like that. X1 and x2. Okay. When x1 is 1, suppose output is 1. Something is mentioned like this. That means here. This point is this. Okay. X1 is 1, x2 is 0.9. So where you will be? Here. Right? X1 is 1 or x1 is 0.9, x2 is 1 means something here again. Very much near to this point. Means, so we can have some values, right? Suppose values is given that some points are lying here. Okay. And some value of x1 and x2 are there such that they are lying here. Right. And some value of x1, x2 are there, they are lying here. Something like this. So what we try to do in the unsupervised learning algorithm, we try to find out patterns among the data. Okay, patterns among the data. So can you find any pattern here, everyone? If you see here properly, there are some data points. Yes, very good. There are clusters, means they are forming clusters here. One cluster is here, right? One cluster is here, right? One cluster is here. So they are forming three clusters. Okay, and we can say that this particular cluster example, when someone is having these features, mean x1, the value of x2 is between this range and this range, and value of x1 in this range and this range, we may say that this is one cluster or this belongs to one class, any class. Okay, class 1, say, or class A, or it may be a horse example. It may be a horse. Suppose this x2 is actually representing your height, and this is representing weight. So I may say this particular, if somebody is satisfying x2 to be x1 between 2 and 3 and x2 between 4 and 5, then they will lie in this particular range, right? They will form a cluster. So we can say this belongs to class A. Suppose this class is what? They are horse. They are horse. Similarly, okay, if the x1 and x2 values are lying between this range like this, and this means your your weight is between 0 and 1.5 kg, and height is between 0 and 1.5 kg. Okay, so we must say this belongs to another class, and suppose this class is a dog class. Height is less, weight is less. Okay, similarly, come here. If x1 and x2 are lying between this range, x1 between this range and x2 between this range, we may say that they belong to a different class. So what we are trying pattern among the data, right? Pattern. And we may say this is nothing but a hippo. Weight is more, height is less. Right? So in unsupervised learning, what we do, understand everyone, we try to find out the patterns among the data. There is no one to help you out like a supervised learning algorithm. You have to find out the patterns among the data, which pattern is there. That is nothing but your unsupervised learning algorithm, in which we will try to find out patterns among the data. So for example, here we find out the pattern. They are forming three clusters. So one cluster we may assign as one class, second cluster we may assign a second class, third cluster we may assign to the third class. Clear, everyone?
sir.
Right? Now you can understand itself. If I ask you semi-supervised, what it will be? Means now,
Combination of the two.
yes, combination of the two. Means you will have mixed kind of data. Means like this, x1, x2, and y. So for some of the data points like 1 and 2, output will be given like 3, 4, 5, 5. But for some of the data, it will not be given like 5 and 3, output not given. 3 and 4, output not given. Again, 4 and 6, output given. 3. Again, 4 and 7, output not given. So we will have mixed kind of data available. We will have mixed kind of data. Some data will be having labels and some data will not be having labels. Okay. So this data point is having label. This data point is having label. This data point is having, but this data is not having label. Okay. So this is what semi-supervised. In this case, normally we take the help of these points which have been given the label to find out the label for this unlabeled data. We take the help of labeled data to find out the labels for unlabeled data. This is what your semi-supervised learning. Right? Now let me come to the reinforcement learning. What is that? Okay. Reinforcement learning. Still, it is huge in research. Research is going on. Huge research is going on. Right? What is this, reinforcement learning? Understand first of all. Reinforcement learning means learning by itself. First of all, learning by itself. Okay, learning by itself. It will learn automatically. So what we will have in reinforcement learning, understand? We have few terms like what? First term is agent. Okay, agent. Second term is environment. Third term is action. Okay, and fourth term is reward. Four crucial terms: action, agent, action, environment, and reward. What do you mean by that? Understand, everyone? Agent is the one who wants to learn. Understand? Agent is the one who wants to learn. Example, a robot or a self-driving car. Or let me give an example, a baby kid who's newborn, an infant, right? A baby who doesn't know anything about the world. I'm relating those. Okay, the agent who wants to learn. Okay, so what that does, I don't understand. Agent interacts with the environment and performs some action on the environment. Agent interacts with the environment. What is the environment? Example, I'm taking an example of self-driven car. So self-driven car is an agent. It is moving on the road. So road is what? Your environment, right? Your road is your environment. On road, what is happening? Different things are there. You have humans roaming on the road. You have other cars roaming on the road. You have bikes roaming on the road. You have animals roaming on the road. Right? So agent will interact with what? Environment and perform some action. What? Example. Your self-driven car is moving like this. Okay? It came. In front of that, a human came. Right? Now, what action he will take? So he interacted with the environment. He's taking some action. Now see. He's taking an action. So what will happen? Understand? Based on what he will do if a human comes. Okay? He will receive reward. Means what he is doing with the human, he will receive a reward. That reward will be positive reward or a negative reward. Suppose this car came and human came in front of him, and what he does, he just rushed over the human like this. Then this self-driven car will reverse what reward? Negative reward. Right? Negative reward. And once it receives the negative reward, next time it will try to avoid that, because the objective of the agent to maximize the positive reward. Maximize the positive reward. Right? Maximize the positive reward. But suppose what happened? The agent was driving on the environment and the human came. But the action taken was what? He just stopped, immediately stopped. Okay. He didn't drew the car over the human. He stopped. So he saved a human life. in that time, it will receive what kind of reward, everyone? Positive reward. So it learned itself. Okay, it received the positive reward. That means I did the correct decision. I took the correct decision, right? That means what? Next time, if a human come, I have to stop. No problem. But understand, when he drove over him, okay, what he received? Negative reward. So next time, it will not repeat the same mistake. So it is learning itself, right? It is learning itself. A very, very simple example. Very simple example. Let me give an example. When my daughter was barely 2 years old, so I was doing some work at the home. So she had a pencil at her hand, okay, and it was a graphite pencil. So what she did in an electricity socket, he put a pencil there, okay, and she got a small electric shock, and she shouted, "Papa, tata ho gayi." Means she got hurt, and after that, means what he received? She was an agent, right? She interacted with the environment. In that case, environment was that electrical socket. And what action he performed? He just inserted that socket there. He inserted that pencil inside the socket. Okay. So he performed that action. And what reward he received? He received electric shock. What was that? Negative. And trust me, after that, he never touched any electrical socket. So what was that? Self-learning. Okay. And same principle is involved here in reinforcement learning. And objective is what? Yes. Right? Getting the point, everyone? So what is objective? Objective is to maximize your positive rewards. This is my objective. Right? This is what is happening. Next time, suppose the car came, human avoided, but what happened? Suppose a car came. Okay, a car came, but what happened? Whenever the car came, it somehow bypassed. Okay, he avoided the collision. So what he will receive? Which kind of reward he will receive, everyone? Positive or negative? Yes, positive, right? When he will receive the positive, it will say, okay, very good, I've done good, right? Next time, even if the car comes, I have to avoid them. But suppose he just collided with the car, then what reward he will receive? A negative reward. So next time he will try to avoid it. This is how your reinforcement learning basically consists of. Basically revolve around your agent, your action that he performs. Okay, what action he's performing, environment, what is the environment, and what is the reward. It's not that easy. It looks like not that easy. That's why the people are researching over it. Lots of research is going on. It is going to be future for sure. But right now the people are doing research. A lot of research are going on. Clear, everyone? Basic three machine learning algorithms are clear. What is supervised? What is unsupervised? If I ask you, what is in which algorithm we have unlabeled data? What will you answer?
Unsupervised.
Yes, very good. If I say labeled data,
Supervised.
very good. If I say partially labeled data,
Semi-supervised.
no. Partially labeled data,
Semi-supervised.
semi-supervised, right? Partially labeled. That means semi-supervised, right? So everything should be crystal clear. What is happening, right? So now we will start our first. Let me see how much time is remaining. At least we can start. No problem. Let me add a new layer. Okay. First machine, first supervised learning algorithm. That is your KNN algorithm. That is your K nearest neighbor. K nearest neighbor algorithm. Okay. This is our first supervised learning algorithm, KNN or K nearest neighbor algorithm. What do you mean by that? Understand, everyone. And also remember, it is also known as lazy learner. I'll tell you the reason. Lazy learner. Second, if you have a huge data set, okay, try to avoid KNN. Don't use it. I'll tell you the reason specifically why. Okay. Remember, first KNN means K nearest neighbor. This K means this K number we will decide. Okay. How many nearest neighbor we will take into the consideration, that we will decide. Okay. It's a lazy learner. I'll tell you why it is a lazy learner. And remember, whenever you are working with a huge data set, try to avoid KNN. I'll tell you the reason why. The reason is because of this, the lazy learner thing. Okay. So how KNN works? How the KNN works? Okay. Understand. Suppose you have given some data set. Okay, and you have two variables there. Example this x1 and x2. Okay, some data points are given here, or suppose yes, whatever it is, some data points are giving here. Okay, like this, and some data points are giving here like this. Okay, and suppose the data set that are given to you, of course, this belongs to suppose class 1, and this belongs to the class 2. Okay, this is belongs to class 1. The upper one that I mentioned here belongs to class 1, and the bottom one that I mentioned here belongs to class 2. Let me mention furthermore so that you can understand something like this. This is dot 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 dot. Okay, so this is belongs to class 2 and this belongs to class 1. See, so what happens in the normal machine learning algorithm? See, what is the process? What is the process? Understand, everyone. Some data will be given to you. Okay, some raw data. Okay, that raw data you will pick it up and you will do the pre-processing on that data. You will do data pre-processing. Okay, this is normal process in every machine learning algorithm. You will do the data pre-processing. After doing the data pre-processing, you will divide your data into two parts. Okay, into two parts. One is known as your training data. Okay, and one is known as your testing data or test data. Okay, a train and test, you can say this. So I will do data pre-processing that so that I can make my data suitable for the machine learning algorithm, and then I will divide my entire data into two parts. And normally how we divide, if we have 100% rows, then around 75 to 80% of the data we keep for the training, and 15 to 20% data we keep for the testing. Intentionally we separate them, 75 to 80% for the training, and rest, suppose we have example 1 lakh rows. I'm giving an example, 1 lakh rows available. From that 1 lakh rows, 80,000 rows, around 80,000 or 75 to 80,000 rows you will use for what? Training purpose. Okay, and remaining 15 to 20,000 rows you will keep for testing purpose. Right, now what we will do on the basis of this training data, we will train our machine learning algorithm. Train means it will try to find out the relationship between input variables and output variables. This is nothing but training, right? It will try to find out the relationship between your input variable and output variable with the help of data. Okay, this is what training will happen. Now training, after training, how will you ensure that my model has been trained perfectly? How will we know that how my model is performing perfectly or not? So what we will do, okay, we will test our trained model. Understand, we will test our trained model. Now model will be tested. Testing of the model, okay, on the test data. Okay, my model will be used and that model will be tested on some unseen data. What is the unseen data? The data that we initially separated for the testing purpose, which is unseen by my machine learning model. He has seen only which data? Only training data he has seen, right? According to which he has find out the relationship. So we will kept some unseen data in the beginning itself, separate. Okay, and now pass my testing data to this and check, okay, how it is given. Means what happened in testing data? Suppose we have x1, x2 and y. So while testing, I will give only what? X1 and x2, not y. If we will say take x1 and x2 and predict y, what is the y? Okay, and whatever y it will do, we will compare this y with the actual y. Okay, so what we will do in testing data, remember, in testing data, when we are doing the testing, we will pass only input parameter to my machine learning algorithm. And we will say, please predict according to you what should happen. Okay, so it will give me some output, suppose y hat. So we'll compare this y hat with actual y. If it is performing good, means both are giving the same result, we will say, wow, my model is performing good, right? But understand how we will assume that. Suppose you pass 20,000 rows, all 20,000 rows is predicted correctly. Perfect. Awesome. You'll see my machine learning model is performing well on the test data. Awesome. My machine learning model is awesome. Okay, or 100% accuracy. Okay, but what happened is that out of the 20,000 rows for the test that you selected, it give me 16,000 rows to be the correct result. Okay, out of 20,000. So how much will be the accuracy, everyone? We can guess. 80%, right? 16,000 divided by 20,000 will be what? Out of the 20,000, how many is correct? How much is predicted correctly, everyone? 16,000. How much percentage will become? 80%. So I'll say my machine learning model is 80% accurate. Okay, but suppose your model performed bad, it's not able to predict correctly. So what you will do? You will go back again after the testing phase. If testing failed, means it didn't perform well in the test data, you will go back again. Okay, either retrain your model, means do the training once again, or change your model, because not every model will be going the same result. There are different machine learning algorithms. So if one machine learning algorithm is not working perfectly, use another machine learning algorithm. Try to retrain or change your machine learning model if it is not giving you the correct result. So what is the process? Understand. First, it gets trained. Okay, but what KNN does, understand, you give him the data, training data you gave him, right? Like this. But KNN does nothing. It doesn't train anything. It says, no, I will not do training. Okay. In fact, you can say it does not have any training phase at all. It doesn't get trained. It waits. Okay. Give me test data, then I will see what I have to do. Very much like your exams approaching. Some students are those who are preparing for the exams. Okay. And somebody are those, okay, no, only on the when the exam paper will be given to me, at that time I will see what I have to do. They have not done any preparation earlier, not at all. Means no training phase. You're not getting trained for the examination paper. Same thing is with the KNN. That's why the name is what? Lazy learner. There is no training phase at all. So you pass training data, it will keep, okay, let it be. Let it with me. I'm not learning anything. Now suppose when the testing phase come, you will pass your test data. Suppose that test data is here. Now at that time, the work will start. Okay. So remember, what is the word? Lazy learner. Why? Because it does not have any training phase. It doesn't learn anything. Right? That's why it is lazy in learning. That's why we are calling it as what? Lazy learner. It doesn't have any training phase. When you will pass the test data, at that time the work will start. So I pass my test data. Okay. Now what it will do? Understand? It will compute the distance of this data point, the test data, with every point which is available in the training data. Compute distance of this with this, this with this, this with this, this with this, with every data point, with this, with every data point, it will compute the distance. Okay, and how it compute the distance? Normally using Euclidean distance. Okay, remember the formula? Under root of x2 minus x1 whole square plus y2 minus y1 whole square. Remember, everyone? How do we calculate distance between the 2 points?
Yes,
right? Yes. Similarly, if you have suppose third parameter as well, you can add it. Z2 minus
1 the whole square.
Right? So it computes the distance of your test point with every training point. With every training point. So let me come to the another page. Okay. So suppose this is your training point and you have 10 training points available. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And this is your test point. So it will compute distance of this with this. Let the distance is A. Compute distance of this with this. Let the distance is B. Compute of distance with this. Let distance is B. Compute distance of this with this. Let C. With this D. With this let E, and so on. Okay. So it will compute the distance of your test point with every training point. Doesn't matter which class it is. Like this, in this, right? What we were seeing. Compute the distance of this test point with every data point. With every data point. And what it does now, after computing that, okay, it sorts the distance. It sorts the distance. So suppose after sorting, okay, and sort the distance in the ascending order. Suppose it found out that this B is the smallest distance. Okay, so it found out B. The distance means the distance between anything you can find out. This is A, this is B, and so on. This is B, this is C example. Okay, so the distance found out is what? A, B, C, D, E, F, G, H, I. How much it become? 5, 6, J. Okay, this is the distance it calculated from the training points. Target calculated distance with every training point, and this was the distance A, B, C, D, E, F, G, H, I, J. Okay, corresponding to any data point, this is the distance, and another data point, this is the distance, another data point, this is the distance. Now it will sort the distance in the ascending order. Suppose the nearest is D, then nearest after the D, the nearest is G. After that, nearest is A. After that, nearest is C. After that, nearest is what? Suppose A, G, A, C, B. Okay, and after that, suppose whatever it is, let's say I. After that, suppose J. After that, suppose H. And after that, suppose E. So this is arranged in ascending order of the distance. Right? Now the term comes. Remember what was the name? K nearest neighbor. Okay, this K we will decide. Nearest neighbor, what we said, remember? Nearest neighbor. That's now picture is coming. That's why we computed the distance to know who is my neighbor and who is my nearest neighbor. Right? That's why the distance was computed. The smaller the distance is, near the neighbor is. Near the neighbor. Neighbor means padosi in Hindi. Right? Same thing. So it computed the distance. So who is the nearest neighbor? Everyone, can you tell me? I arrange this distance in the ascending order. So who is the nearest neighbor? D. Right? D. Then G. Then A. Then C. Then B. Then actually this number we decide how many nearest neighbor we have to consider. And normally we consider this to be odd number. I'll tell you the reason. We consider to be odd number. So suppose I decide K will be 3. Means 3 nearest neighbor will be considered. 3 nearest neighbor will be considered. So what will be these 3, everyone? D, G, and A, right? 3. So now what it will do, suppose this is the classification task now, which class it belongs to. This is the task, okay? So we'll check what is the class of D. Okay, so D was the distance with respect to some data point, right or wrong? D was the distance corresponding to some data point in the training data. So which class it belongs to? Suppose it belongs to class 1. We'll mention that. Which G is also corresponding to one training point. What is the class of this? Suppose again class 1. Again next neighbor is what? A. Suppose this belongs to what? Class 2. These are the distance corresponding to data points. Okay, this may be this data point. Example this. And suppose this is belongs to class 1. Again, this G is corresponding to suppose this G. And this also belongs to class 1. This A is corresponding to suppose this one. And it belongs to class 2. So we mentioned this, okay? Distance is there. These distances are corresponding to data point. Now we'll check, okay, D is distance with respect to which data point? And that data point belongs to which class? Class 1. G is distance with respect to one data point. That data point belongs to which class? Suppose class 1. A belongs to what? Another data point, right? Distance with respect to another data point means distance of target with respect to these data points, right? Distance of target from these data points, okay? Not target, I should say test. Distance of test point with these data points. Distance of test point with these data points, right? So this belongs to class 2. Now it will check, okay? Class 1, class 2, class 3. It is saying class 1, it is saying class 2, it is saying class 2. So can you tell me which will have the higher probability, everyone? Belonging, class 1 or class 2?
Class 1.
Right? So it will say that your test data point belongs to which class? Class 1. This is your final conclusion. This will be your class 1. And now you can understand itself why the odd number has been chosen. Can you guess why? If I would have chosen even number, suppose 4 I mentioned, then this will also take into the consideration, right? So there may be possibility of what? This is class 1, this is class 1, this is class 2, and this is class 2. Now what conclusion you will make? Can you make any conclusion? 2 points are saying class 1, 2 points are saying class 2. Both are having same probability, right or wrong?
Correct.
Right? So to avoid that, we should have a guaranteed decision. We always choose what? Odd number. So that one class should have a higher probability. That's why it is always chosen to be odd number. Tell me, everyone clear? So what will happen? I repeat once again, very, very simple scenario. Suppose this is our X1, this is X2. These are our training points. Okay, belong to some particular class. These are our again training points. Belong to some particular class. In KNN, there will be no learning phase. When the test data will be given to us, this is my test point. The distance of this point will be computed with every other data point in the training data set. Right? And after that, your distance will be sorted. The distance will be sorted, and accordingly, what will be picked? Whatever number we will specify, k is equal to 3, or k is equal to 5, or k is equal to 7, or k is equal to 9. According to that, neighbors will be chosen. Now we will be check. Okay, suppose we picked 3. So first distance is what? D. D is respect to which data point? That data point belongs to which class? We will notify that. G belongs to which data point? Notify that. Okay. Sorry, G belongs to which class? Notified that. A belongs to which class? Notified that. Among that, whichever is the maximum class. Okay. Whichever is the higher mode, class 1 or class 2, that will be picked. Which is coming more? Class 1. Of course, that means the probability of class 1 is more. What is the probability? 2 by 3. Because we have 3 points. And what is the probability of class 2?
1 by 3.
1 by 3. So which is the higher probability? Class 1. So you will say that my test point belong to which class?
Class 1.
Class 1. Clear, everyone? Why it is called lazy learner? Is that clear?
Sir.
Right? First of all, why it is called lazy learner? That is important. And what is the drawback? See, why I said for a large data set it should not be used, because
Time.
when I will pass my test data during runtime, when the test data will be passed, it will be using all the data set at the same time. Training plus testing. It will be using all the data set, means this will occupy your RAM. Everything will be available in the RAM. Training plus testing. So unnecessary, it is going to occupy what? Huge amount of RAM, which is not a good thing. But remember, in other algorithm, training phase will happen. So training will happen. After that, training will happen. You have equation. You learn the model, right? So when you will pass your test data, directly this equation will be used to do the prediction. So training and testing will not come together. So they will occupy less amount of RAM. Clear, everyone?
Yes, sir.
Right? Last, this is the classification problem. But suppose it may be a regression problem. Regression means, suppose some parameters are given and you have been to ask, please predict the price of the petrol. So price of the petrol is what? A continuous numeric output. It may be 92.3. It may be 94.7. It may be 94.75. It may be 98.23. Continuous numeric output it is. Okay. Similarly, tell me, everyone, if I ask you the house price will be what? A classification problem or a regression problem?
It will be a regression problem, sir.
Yes, very good. Classification means belong to some particular class, like male or female, survive or unsurvive. Like similarly, if I ask you petrol price will increase or decrease, just predict this. So it is a classification or a regression. But increase or decrease, just type this.
It will be classification.
Classification. But I said, no, tell me what is the price, exactly price. Then regression, right?
Then
now
regression.
So suppose you are solving regression problem with the help of k nearest neighbor. In that case, what will happen? See, of course, in this case, we will not calculate class 1, class 2, and class 3 and calculate probability. We'll see what we have picked 3 points, right? So what is the stock price or price of the petrol corresponding to D point? Corresponding to D point, what is the price? Suppose 4. What is the price corresponding to G point? Suppose 6. What is the price corresponding to A point? Suppose 7. So what KNN does? Suppose you consider K is equal to 3. So for D, price is this. For G, price is this. For A, price is this. It's a label data. Na? So already output is given for the training data. This is the stock price. This is the stock price. This is the stock price, or this is the petrol price. At last, what will happen? You pick the 3, then 3 neighbors, then both this 3 will be taken and their mean will be calculated. 4 plus 6 plus 7 divided by 3. If you have selected 3. If you have selected 5, then 5 data points will be taken. Their corresponding output value will be taken and their mean will be taken. Here we have taken 3 values, 4, 6, and 7. So their mean will be what? 4 plus 6 plus 7 divided by 3. What will be that? 10 plus 17 divided by 3. It will be, I think, 5.66. This will be your final output. Tell me, everyone, is it clear?
Yes.
How regression problem will work with the KNN? Okay,
yes,
both should be clear how classification works and how regression works. Okay, next we'll continue, I think, on Monday. Fine, everyone? Is it okay?
Yes.
Sir, small doubt.
Yeah, tell me.
Sir, in classification problem, how do we define that from which class this point belongs? Like you said, this D belongs to class 1, G belongs to class 1.
Here I'm just giving an example. It will be given in the training data. Okay. It will be giving in that. For example, remember we saw the Titanic data set example, or
yes, sir.
Remember, let me just read it if it is available. DF is equal to PD Let me import it. I don't know. It is import pandas. I think we have imported that. Let me directly use df is equal to pd.read underscore csv, and file name is, I think, titanic.csv. Let me read it. No, it is not there. Okay, I have not imported that pandas. Import pandas as pd. Yeah, now let me read it. See, if you see this df.head, close. See, this is my survived column. So actually, this is the classification task, whether the person will survive or not. Okay, whether the person will survive or not. So if you see, this is one data point. The first row is one data point. So this is my what? Output column is given to me, and the input parameters are given to me: passenger class, name, sex, siblings, abroad, breed, and fare, right? And what I have to predict based on these parameters whether the person will survive or not. Okay, so we have labeled the data given. Already some training data is given to us. 0, 1, 1, 0. In every row it is mentioned. See which class this data point belongs to. Can you see here? 0,
Yes, sir.
1. So from this we are guessing. I will just explain random. This is assumed to class 1. This is assumed to class 2. Automatically it is seen from the training point which class they belongs to. Already it is mentioned, right? 1, 1, 1, 1. So automatically when it will calculate the distance, automatically to understand, okay, what is for this particular data point, what is the corresponding class? For this particular data point, what is it? Suppose it find out this is the nearest data point. Suppose this one. Okay. So first one, this one, and suppose this one. 0, 1, and 4 are nearest to my test data point. Okay. So what it will check? What is the class of 0 data point? What is that?
0.
0.
Yes.
Okay. Suppose these are the three nearest. 0. Example, I'm giving 0, 1, and 4. So what is the class of 0? 0. What is the class of 1?
1.
1. What is the class of 4?
0.
0. So which is more? 0 or 1?
0.
0. Right. So my test data point belong to which class?
0.
Class 0. Clear, Hardik? Now?
Yes, sir. And sir, one more thing.
Mhm.
All the machine learning problems that we face, so are they only divided in regression classification, or is there something else except for regression and classification?
No, actually, there are different things available as well, but broadly there are machine learning. If you talk about the machine learning, the broadly there are two. But actually, what happens if we go ahead depends on. Suppose you are doing time series forecasting. So in that we have other algorithms as well. Other algorithms as well which are available. But broadly, if you talk about broadly, take a big leap. Okay, in that big leap we have supervised, so unsupervised, semi-supervised, and reinforcement learning. Okay, within that you can divide further if you want, but broadly these are the main that we discuss about. Okay, means these are major categories. Within that we have subcategories that you want to use.
Okay. So,
Okay,
sir, is this classification and regression is separate from is classification and regression is part of any of this four, or is it a completely separate way of?
no, class. These are the type of supervised learning algorithms are there. Na? So in supervised learning algorithm also, see, same algorithm is there, KNN, supervised algorithm, because we have
Yeah.
given the label data. But from the same, what we can do, we can perform two kind of tasks: regression as well, classification.
Yes.
Okay, these are two different tasks that can be done by a supervised algorithm. Getting my point?
Yes. Yes. So there are tasks. These are not types of machine learning and
Yes,
algorithms.
yeah. These are tasks that you have to do with the help of machine learning algorithm. What task you want to perform? Regression or
Classification.
classification? Getting the point? For example, this is what? This is a classification task,
Yeah.
right? This is the classification task that you have to do. Clear?
Clear, sir. Clear.
Okay. I'm ending for the day, everyone. See you on Monday. Okay.
Yeah. Thank you, sir.
Okay, everyone. Bye bye. Take care. Okay. Bye. Or if tell me one thing more, everyone. Are you there?
Yes, sir. Yeah.
If you are free tomorrow, I can take the class tomorrow.
Yes, sir, I don't have an issue.
Otherwise,
Yeah.
If
please.
the time is same.
The time will be same. Time will be same, or half an hour or 15 minutes here. It can be there. I will keep the same time. No problem.
Yeah.
Yeah,
No
no
issues.
problem, sir. No issue.
Okay. So I'll take tomorrow. Fine. So at least it is in the fresh mind, so it will be easier to implement that. Otherwise, on the Monday, most of the things will be forgotten. That's
Yeah.
what I believe. Okay.
Tomorrow 6:30 p.m.
Yeah, 6:30 p.m. Right. or we can make it 7 if fine, if you are okay with that.
Yeah,
Yeah,
it's
no
okay.
issue at 7
Okay,
also.
okay, okay.
Okay.
7. I will keep it 7. I think that will be fine. Okay.
Okay, sir. Okay.
At 7 we'll keep
Yes.
7 to 8. We'll take the class. Fine.
Okay.
Fine, sir.
Okay. Okay. Bye bye. Take care tomorrow.
Yeah, see you, sir.
Yeah. Yeah. Okay. Bye.